So this next example asks us to show that the two lines that we are looking at here intersect and find an equation of the plane that contains the two lines. Well, first thing first, let me point out that in higher dimension, it could be possible that we can have lines that are not parallels, but they do not intersect as well. So in this case, if I like to show that the two lines that we have here intersect, so it could look something kind of like this. So I like to show that the two lines intersect. I'm gonna need to find the intersection point. I'm gonna need to find the coordinate for the blue point here where the blue line, where the two orange lines intersect. But if you try to do this by setting their x coordinate, their y coordinate, and their z coordinate to equal, I'm gonna have 4t minus 1 equal, 12t minus 13. And then t plus 3 equals 6t plus 1, and 1 equals 3t plus 2. Now, if you try to solve these three equations, you're not going to get an answer, and this is because the two things that I'm looking at here, these are parametric equations. These are parametric equations. So the underlying variable t here, they actually are not the actual coordinate, it's just an underlying variable. So, at the intersection point, the value of t in the first set of equations and the value of t in the second set of equations could be different. So, what I need to do is, I need to change the variable for one of the set of equations to be something else. So, in this case, I'm gonna change the variable name for my second line, 12t minus 13, 6t plus 1, and 3t plus 2 to something else. So let me just call that s here. So now I can go ahead and solve this set of equations. Let me just write out the answer. I'm gonna get that my s is gonna be, negative 1/3, and my t is gonna be negative 4. So then my x coordinate, this first guy, is going to be negative 17. My y coordinate, the second guy, is negative 1, and my third guy, the z coordinate, is going to be just, 1. So that means the coordinate for the intersection point, this is going to be, this is going to be just negative 17, negative 1, and 1. So now I'm done with the first part. I have already shown that these two lines, they intersect. But now I need to find an equation of the plane that contains these two lines. Well, there are many ways we can do this. Let me talk about the first way. I'm gonna use the vector value parametric equation form first, and that is because, I knew that my plane is going through this point, 17, negative 1, and 1. 17, negative 1, and 1. And I knew it has to contain the two orange vectors here, and the two orange vectors, I can read them off from the equation of the parametric. I can read them off from the parametric equations that we have here. So I can use that as the vectors that generate my plane. So if I rewrite this guy, by the way, so the first one, I can rewrite them as, my xyz is just going to be 4t minus 1, and then t plus 3, and then 1. I can also rewrite this as t times 4, 1, 0 plus negative 1, 3, 1. Notice how the last form here, this is just reading off the coordinates from my equations here. So I'm gonna have 4 and 1 and 0t here, and that's what goes in here. And I'm gonna have the constants as the negative 1 and 3 and 1, and that's what goes in here. So that means the orange vector that I'm looking at, this orange vector, is going to be just 4, 1, 0. So that will go in the equation for my plane. So that's going to be plus some constant t times, 4, 1, 0. And as for the other guy, the equation form in the matrix form for this line is going to be, t times 12, 6, and 3 plus negative 13, and then 1, and then 2. So this guy, 12, 6, and 3 is going to be the coordinate of my second orange vector that generates my plane. So in this end, I'm gonna have this guy plus another variable s times 12 and 6 and 3. So here's my equation of the plane. This is in vector value parametric form, by the way. Let me kind of redraw this. Now let me show you another way that I can also find the equation for this plane. I can also do this using the vector, the normal vector as well. My normal vector, the black vector, is going to be the vector that is perpendicular to the two orange vectors, and I can find that using the cross product of vectors. So I can compute the determinant of this matrix of I, J, and K, and then my second row is going to be 4, 1, 0 here. This is 4, 1, 0. And my third row is going to be 12, 6, and 3. 12, 6, and 3. So now, let me kind of move this a little bit. If I multiply down, I'm gonna get, 3i. I'm gonna get 0 here, and I'm gonna get 24k here. 24k. I multiply up and get 12k here. I get 0 here, and I'm gonna get 12j here. 12j. So the determinant of this matrix, which is going to be the coordinate for my black vector, is going to be, negative 3i, and then plus 12j, and then minus, minus 12k. So that means the coordinate from my black vector is going to be just negative 3, 12, and negative 12. Now then, I knew that the equation for my plane is then going to be negative 3x plus 12y and minus 12z. And minus 12z is going to equal to something. Let me call that d for a moment. Once again, whenever we have the coordinate for the normal vector, I can just simply pull out the coefficient negative 3, 12, and negative 12 here to be just the coefficients for my x, y, and z. And now to find the d here, I'm just gonna have to plug in one of the points that I knew lies on the plane. In this case, I knew that the point negative 17, negative 1, and then 1 lies on the plane. So what I'm gonna have is, negative 3 times negative 17, so I'm gonna get 51, plus 12 times negative 1, so I'm gonna get negative 12, and then minus 12 times 1, so that's a minus 12 as well. So I'm gonna get that my d is gonna equal to, 51 minus 24, so that comes down to 26, I think. Wait, no, it's negative 27, so I'm gonna have to negative. No, I'm gonna have 27 here, just 27. Okay, so this is what I'm gonna get. In the end, the equation for my plane is going to be negative 3x minus 12y, negative 3x plus 12y minus 12c is going to equal to 27. I can divide 3 on both sides, so what I'm gonna get is negative x, and then plus 4y minus 4z is going to equal to 9. So here is my other form for the equation of this plane.